so you can watch it later if you need to. Okay, so on what intervals is this decreasing? So if I want to know where a function is increasing or decreasing, what calculus thing do I need for that?
First derivative.
Okay, so first derivative. So my first concern would be that you took this derivative correctly. This has to be product rule. It's x times the square root of x plus 3. You can't rewrite this with algebra or exponent rules. You have to do product rule. So derivative of x times x plus 3 left alone plus x left alone times the derivative of x square root of x plus 3. So we would bring the power down, lower the power by 1, consider chain rule, but it would just be times 1. Okay, are you good with that as first derivative? Okay, to know where it's decreasing, I can either check every x value possible, which is going to take your whole life because there's an infinite number of x values, or you can test around where it might be changing direction. The places where it might be changing direction, we call those what? So critical numbers. And how do we find critical numbers from the first derivative?
Set equals 0.
Okay, figure out where it's 0 or undefined. Now, I'm going to guess that this might be where you slow down a little bit, because trying to figure out where this equals 0 is a little bit problematic. And figuring out where it's undefined is also a little bit of an issue, not as much. But do you agree that if I can make this look as one big fraction, like this, you agree that it's pretty easy to figure out where this equals 0? Because it's where the numerator equals 0, and undefined when the denominator equals 0. That only works if it's written as one big fraction though. This is not one big fraction yet. So probably what some of you did not consider or try yet is we can make this one big fraction by getting a, let's just multiply these, getting a common denominator to push these together as one big fraction. So between 1 and 2 square root of x plus 3, what would be the least common denominator? Okay. This denominator had that, or this fraction already had that denominator, so I don't need to multiply his denominator by anything, so I should not be multiplying his numerator by anything either. So the plus x stays the plus x. But over here, to make this guy have a denominator of 2 square root of x plus 3, I have to multiply his denominator by 2 square root of x plus 3 and his numerator. That way it's like I'm multiplying by 1 and not changing the size. So now that he's over 2 square root of x plus 3, I can put him as this big fraction here, and I've got 2 times, what's the square root of x plus 3 times the square root of x plus 3?
X plus 3.
Okay, and it was 2 times all of that, so not 2 times x and then a 3. It's 2 times x plus 3. So that's like 2x plus an x is 3x. You can simplify that more if you'd like to. You could factor out a GCF out of the top, but this is plenty fine for me. Because if we needed critical numbers, I needed to figure out where this equaled 0. And now that it's one big fraction, I can just figure out where the numerator equals 0 and where it's undefined. And since it's now written as one big fraction, that would be where the denominator equals 0, which would be at x equals -3. So again, sometimes, I don't know on this circuit if it actually ever happens, but sometimes that's all you're asked. What are the critical numbers? But then sometimes you need to use this information to figure out where it's increasing, decreasing. And sometimes you need to use this information to figure out relative maxes and relative mins. Okay, so I did all of that just to figure out that it might be changing direction at -3 and it might be changing direction at -2. So to know if it was increasing or decreasing to the right of this, we need to plug in any number to the right of -2, like maybe 0. We plug that into the first derivative. If you care about increasing, decreasing, you'd be left with a positive over a positive. so the function is,
Positive.
the derivative is positive, so the function is increasing. To know what's happening to the left of negative 3, I need to plug in any number. This guy was positive. Any number to the left of negative 3, like maybe negative 4. And again, luckily, we don't have to get a specific number. We just need to know if it's positive or negative. So plugging in negative 4 to the numerator goes negative. When I plug negative 4 into the denominator, what happens? I'm sorry, one more time?
Or it's imaginary.
It's imaginary. You get the square root of a negative number. And where do imaginary numbers show up on your graph?
As asymptotes.
No, imaginary numbers don't show up on your graph. Something like 2i is nowhere on your graph. So what that means is x equals negative 4, if it doesn't have a slope over there, then, and it didn't have a time to change direction because there was no critical number there, I bet that part of the graph doesn't exist. So I'm going to put an x there. We'll graph it in just a second. I bet it doesn't even exist left to negative 3. Okay, and then this one's a little scary because between negative 2 and negative 3, I don't know, we could try negative 2.5. That's a little harder to do without a calculator, but that would make the numerator negative, the denominator positive. A negative divided by a positive is negative. So when is my graph decreasing? Between negative 3 and negative 2. Okay, and then as I said, I would graph the function. It is x square root x plus 3. So here's what the original function looked like. So notice when we tried to plug in negative 5 and we got or negative 4, we got an imaginary number. As I said, that means that the graph's not going to exist. Then we saw that it was decreasing from negative 3 to negative 2, correct? And from our work, it wasn't part of our answer, but it was increasing from negative 2 to infinity. So we are analyzing that function without the assistance of seeing its graph. Okay, so several of you were going to ask about this one. So just to help pinpoint, my guess is you guys struggled to go from the first derivative looking like this. You maybe didn't think to get a common denominator and make the first derivative look like that. Was that the main issue?
Mm-hmm.
So you don't have to do that often, but it is pretty necessary when you need it. So.